Hey, everybody, appreciate y'all hopping on. We're still a few minutes early before 11 o'clock, so we'll give it a few minutes, let some more people hop on, and then kick the webinar off. All right, thanks again, everybody. We're gonna give it one more minute here, and then we'll go ahead and get started. Okay, I think we have a quorum. Want to welcome everybody to our monthly webinar series that Swagelok, Georgia, Jacksonville, South Carolina has been doing this year. And my name is Dayton McCraw. I serve on our outside sales team, and we'll be facilitating the Q&A portion today of the webinar. So when we start the presentation, if at any time you see something that kind of piques your interest, or if you have a question about it, if you look down at the bottom of your screen, there is a Q&A button that you can hit that we'll be monitoring throughout the presentation. So feel free to ask any questions at any point in time, and we'll stop and work through that together. We're going to spend about the next 45 minutes talking through pressure gauge failures, some of the things that we typically see in the field, and some of the things that you can do to mitigate those failures for, like I said, about the next 45 minutes or so. I also have the distinct pleasure to introduce today's presenter, and that is Mr. Dan Dupler, who has been a member of our sales team for about 16 years now and has served a wide range of customers from pulp and paper to automotive, tire, chemical, and power. So he's kind of like the farmer's insurance guy. He knows a thing or two because he's seen a thing or two. So with that, I'm going to hand it over to Dan. And like I said, at any point in time, if you have questions, just feel free to type it out, and we'll see what we can do about answering it.
Thank you very much, Dayton. Appreciate the warm introduction. And I also want to thank everybody who has signed up and attending our webinar this morning. We really appreciate you cutting out 30 to 45 minutes to spend with us here talking about pressure gauges, and we hope you take away some advice and some new information that you don't have currently in order to prolong the lifespan and choose carefully these delicate instruments that we're going to talk about today. So we're going to look at the agenda. And where we're going to start is looking at the pressure gauge itself, how it operates, how it's built, the components that go into that pressure gauge in order to monitor pressure. We're going to look at the failure modes and why they sometimes stop working, why they are not working. And not only are we going to look at the failures, we're going to look at solutions and how to avoid those failures in the future. We're going to spend just a couple of minutes talking about options and accessories that you may or may not be aware of that Swagelok does offer with our pressure gauges. And then the last slide that I want to go over and make sure I arm everybody with is the proper gauge selection guide, because this is really the information that you'll need moving forward in order to specify pressure gauges for longer life, better, more accurate sensing in your facilities. So with that, I do want to mention that I did this on purpose. I didn't put any formal question and answer areas in the agenda. This is for your benefit. We'd like to keep this as interactive as possible. So if you have a question, if there's something that doesn't make sense, if you want more clarification, please feel free, like Dayton said, to use that Q&A option down at the bottom of your screen. We'll address it as we go, and if we can't answer it, we'll certainly follow up with you after this this webinar today to make sure that we get that question answered. So, like I said, please be aware that you can ask questions at any time. So with that being said, we're going to go ahead and get started with the pressure gauge itself. So the pressure gauge starts with this pressure connection. So this is where you have a wide variety of different options to connect your pressure gauge to your system. Later on, we're going to talk about the Swagelok tube adapter and how that works with having a easy to align pressure gauge, but just know that there's a lot of options, whether it's NPT, tube adapter, flange, There's just a lot of different ways to connect to your pressure. But that's where the action starts. So we've got pressure coming in into the pressure gauge through our measuring element, what we call the Boredom Tube. And I apologize for my shaky hand there. I've never been confused with a surgeon, so I did want to just show you where that pressure does come from. So it's in our measuring element, which we call a Boredom Tube. And that Boredom Tube is made by using a Swagelok gauge used with 316 stainless steel tubing, and it's formed into an oval shape, and then it's bent into a C shape, and then it's installed inside the pressure gauge, connected by the end piece with this pull rod. And so this linkage is connecting that Boredom Tube where your pressure is, your system media and your pressure is inside of that Boredom Tube, connected to this movement, which moves that pointer. So that's how you get your reading on the pressure gauge itself. It's through that measuring element called the Boredom Tube. So we're going to look a little bit more closely at the Boredom Tube and why it's such an important piece of this pressure gauge. So you can see on my pointer here, this is the cross section of a Boredom Tube as it's flattened into that oval shape. And all of these images on here, when you see the dotted line, this is when pressure is introduced. So what that Boredom Tube, what it wants to do when it senses pressure, it wants to go back to its original round shape. And it also wants to straighten out away from that C shape here that we have on this Boredom Tube. So what that does is that gives us that movement and that action to move that pointer. And another closer look at the Boredom Tube. So with our pressure gauges, you have a low pressure gauge, like a 0 to 10 PSI pressure gauge. That Boredom Tube has been built with a very thin wall piece of stainless steel tubing. The higher pressures that you go, so looking at like the 0 to 10,000 PSI or the 0 to 100,000 PSI range, obviously it's going to be a much thicker wall on that Boredom Tube. And so as we go into the failure modes and talk about what happens when these stop working, that's going to be really important to visualize and think about, okay, this is the reason why this is failing, and that's how a Boredom Tube is built. So hopefully that makes sense to everybody. So that's one way to make a connection to the pressure gauge through that Boredom Tube. Another way to do it is using a diaphragm seal. So if you look at my image on the left, so this top half of this image is just a standard Swagelok tube fitting with a Boredom Tube. But what we've introduced here is a lower housing that contains a diaphragm here. So what this lower housing containing that diaphragm does is it allows us to create a barrier between the system media and the fluid that is in that Boredom Tube. So as pressure is introduced into this lower housing, it's contained here under the diaphragm, and that diaphragm is just moving slowly up and down, creating that pressure into that Boredom Tube, and that's moving your pointer. So a little bit closer look on the right, you'll see the diaphragm and how that works and how that's designed. So this isn't the last time we're going to see this diaphragm seal, but I want to just take a minute to show you a different way to do it and how that might be an option or a solution if you have some gauge failures. So speaking of gauge failures, it's not often that we have a presentation or getting in front of folks and talking about how things don't work. So this is one of those rare instances where we're happy to show you why things don't work in an effort to avoid those in the future. So some of these pictures are going to be pretty surprising on how bad these gauges have failed. But I do want to take a second here, and I want to open up the Q&A tab, because what I'd like to do from the group is get some guesses to our poll question that we have here. So I'll read it to you. It's estimated that blank % of installed pressure gauges have failed or are in the process of failing. So Dayton, if you could monitor the Q&A, and folks, if you could give us some estimates on what you are guessing that gauges have either failed or are in the process of failing. And Dayton, if you could shout out a couple of those guesses in the Q&A.
Yeah, absolutely.
All right,
Let's
sounds
see, we
good.
got some. So we've got one in right now at 15%,
Okay, good guess.
20%, getting closer, 100%. All right.
Okay, we need to take that conversation offline.
Yeah. 30% from, yeah, 30%.
Cool. Okay, well, we're really close. So we estimated it's at 40%. That's a really big number. So that's why we're here. That's why we're talking. I assume that's why most folks have signed up to spend these 30 to 45 minutes with us to talk about the failures and how to avoid them. So we have narrowed down these failures into 8 categories that they seem to most of the time fall in line with. So we're going to talk about pressure spikes, what that looks like, and how to avoid it. Overpressure, mechanical vibration, pulsation, temperature is a big one. In my image here that shows a hot gauge or high temperature, but it could also be low temperature. So, high and low temperature, that's something to consider. Corrosion and clogging can obviously lead to gauge failure. And then the last one we look at is mishandling and improper use. And I would also put installation in that grouping as well, because a poorly installed gauge can absolutely fail. It'll either fail or give you false readings. So let's look a little more closely at the first one, in this pressure spike. So I've got a couple images of gauges that we've seen in the field that have experienced a pressure spike and now they're failing. So as you can see, the dead giveaway is on these pointers. So this is what we call our a fish hook pointer. It's deformed, and what has happened is in this scenario, I'm guessing, because I wasn't there when this happened, but I'm guessing that the pressure was somewhere in the 150 psi range. It's the gauge is doing its job, and then somewhere upstream, something catastrophic has happened. A valve opened, something happened that caused a huge spike in pressure. So this pointer is violently coming around, swinging around past the 300 psi maximum range, and it's slamming into this point, or into the stop pin. And I mean, you can imagine the force that it would take to actually bend that pointer is probably pretty high. So again, that's a catastrophic failure somewhere causing it to spike. So one of the symptoms is this fishhook bent pointer. That's really not the worst thing that can happen. What I would be concerned about is what's happening behind that dial face, inside with all the with the movement and the linkage and the Boredom tube itself. Because what I suspect has happened is that Boredom tube has either really stretched out due to that big pressure spike, or worst case scenario, it's actually ruptured. So if you have a rupture in your Boredom tube, it's essentially just a piece of tubing that has ruptured. And so now you have, whatever your system media is, just leaking through the valve, and it's, piling up in the gauge itself, or it's, venting to atmosphere. So now you've got a big problem. So that is, an issue that would obviously need to be addressed.
Hey, Dan.
Yes, sir.
We do have a great question here.
Yeah.
Brian has asked, does this same principle apply to vacuum gauges as well? Can you run the risk of this with a vacuum gauge?
Yes.
Very good. Thank you.
You're welcome. Good question. Thank you for asking. So yes, that same thing applies with a vacuum gauge. So for a solution for a big pressure spike like this, what would be a possible solution? Well, the first one that comes to mind is liquid filling the gauge. As you can see, neither one of these are liquid filled. So this liquid filling, you've got a couple options. You can use a glycerin, you can use a silicone to fill the gauge. And that filling not only lubricates all those moving, working parts in the gauge, but it acts as it acts to slow down the whole movement of it. So that pressure spike, it's likely never going to happen where that pointer comes around and hits that stop pin. So it's just slowing everything down with the liquid filling. So the next one we're going to look at is overpressurization. So I'd like to open it back up to the group and have someone just give me a quick summary on what they think is going on here with this gauge. Just feel free to let us know your diagnosis in the Q&A. And Dayton, if you could let me know what you see as far as some guesses on what's happening here.
Yeah, you got it. Overpressurization. Very good.
Yep. I guess I gave it away by putting overpressure on there, didn't I? Should have taken that off.
Yeah. Yeah. No regulator, which could very well be something as well.
Yep. Guys, I appreciate the comments, and you're exactly right. There's too much pressure here. It's not regulated. This is the wrong gauge for this application. So you can see, if you look closely here, my pointer is on the wrong side of this stop pin. So I'm going to guess that this is reading up to 1,000 PSI, sort of as a minimum. So this gauge is rated for a maximum pressure of 600 PSI. And as it's come here, I mean, it is pegging out on this stop pin. So there's a couple things at play here. I really want to talk about availability and stocking of gauges, because we see this all the time where folks install gauges that are in stock, they're in inventory, they grab something that's kind of close without really doing the due diligence and figuring out what their optimal pressure is in that system, and then using the correct gauge for it. So I get it, it's on hand, let's install this gauge and move on and do something else. So I get it, it definitely happens, but this is where you run the risk of using the wrong gauge, because at some point this is going to wear out. It's just not designed for this high of pressure. This particular pressure gauge is in an ideal situation would be sensing 300 PSI, not over 1,000. So our solution for this would be choosing the correct dial range and using the right gauge. So a helpful rule of thumb is, number one, you have to find out what is your optimal operating pressure in that line. So for the slide I've got up here, it's 100 PSI. That's my ideal range for that pressure to sense. So I would double that to 200 PSI, and I would specify, buy, and install a 0 to 200 PSI pressure gauge. So if anybody has any questions about that, let me know. But that's a good rule of thumb on how to use the right pressure gauge. So this poor pitiful pressure gauge we're looking at now has reached the end of its life. You can see the pointer is just down at the bottom of the case. It's likely rattling all over the place. When we see gauges installed into heavy vibration environments, the pointer comes off, that black dust starts to build at the bottom, and that thing just rattles around, and obviously it's not sensing pressure. Things have gone off the rails here with this one. So one of the solutions would be to move the pressure gauge away from the compressor, the pump, whatever's causing this huge amount of vibration. In the real world, is that always possible? No, it's not. So one solution would definitely be to liquid fill that gauge, again, just to slow all that movement down, and just, instead of it just rattling like crazy, slow everything down with that liquid fill. So next one we're going to look at is pulsation. And I can assure you that's not a hummingbird trapped inside of that gauge case. That's the actual pointer that's just wildly fluctuating between 100 and 200 PSI here. So we've got some issues here. Liquid filling it would certainly be an option, but we've got another option for that as well. You could install a snubber fitting kind of the same theory as far as slowing that system media down into that bored-on tube, but this uses a filter element built into that snubber fitting that can easily be installed at your connection to the system. We're going to look at corrosion on these. Yeah, the one on the left, you know, we're not really getting a very good reading on the pressure in that system. You know, there's just so much corrosion built up inside of that. It's not doing any good. It's not working. The one on the right, we've taken the back off to do a post-mortem on what's happening with this gauge. And as you can clearly see, that bored-on tube is corroded. The movement looks okay, or the linkage looks okay, but the movement here is starting to rust. So whatever media flowed through here, it does not play nicely with whatever this was made of. So one solution would be, quite frankly, to buy a better pressure gauge, one that uses 316 stainless steel components if it's compatible with that system media. Another solution would be to use our friend the diaphragm connection. So that diaphragm seal, again, creates that barrier. So that system media is never going to see the inside of that bored-on tube. So that would be a solution for that corrosion issue.
Hey, Dan.
Yes.
We have another great question from Mr. Joel Looper,
Cool.
And that is, what determines which type of liquid fill we need to use in a gauge?
That's a good question, Joel. So temperature is a big one. We make a low temperature glycerin. So the first question that I would ask is temperature. But thank you for asking, Joel.
Awesome.
Cool. Somebody else was probably thinking that same thing, so thanks for asking. So the next one the next failure mode we're gonna talk about is clogging. The image on the left is, I'm gonna go out on a limb and assume that this has been installed correctly, it was chosen correctly. The desired pressure is 30 PSI in the system, so this has been chosen a 0 to 60 pressure gauge, just like we would recommend. And it's sensing 1 pound of pressure. So pressure is getting to that bored-on tube. It is registering on that pointer. However, it's not enough. So something's going wrong. This is a small orifice, as you can see inside that, that pressure connection there to the gauge. So it's likely that it's clogged. So a solution to that would be to use our diaphragm seal again, just keeping that barrier between the bored-on tube and the system media. So I know we haven't talked about steam yet, and I would like to address it. So the image that you're seeing here is the first stage steam. I don't know if the second stage steam is any better than this one. I would hope so, because this one's kind of hard to look at. But so what we've got here, I'm guessing, is that steam has entered the pressure gauge, and it hasn't been properly cooled. So that steam has likely caused a rupture in that bored-on tube, and that condensate is just filling the gauge. That's not a halfway liquid filled gauge either. That is condensate that's just trapped inside that gauge. So what's the solution for that? How do we avoid that in the future? So you've probably seen the image on the left in different scenarios, a pigtail siphon. Basically, all that is doing is just cooling that steam before it makes contact with the inside of the pressure gauge. Those can be tall and take up a lot of space. So if space is an issue, the image on the right might be a possible solution for you. It's a mini siphon, and it just takes up less space, but it does the same thing. It just cools that steam before it hits the internals of the pressure gauge. Now, the next one that I want to show you, there's a lot going on in this picture. I get it. We can avoid the fishhook pointer, the melted lens, the corrosion that's going on in there. There's a lot going on in there that we have already addressed. But what I really want to talk about is right here, is this pipe bushing that has introduced 2 more potential leak points for the installation of this gauge. So that's an issue that we would try to avoid using a bushing and like I said, introducing potential more leak points. But the alignment of that pressure gauge, it's behind a big eye bolt. I can see that there's a piece of equipment above it. It just, to me, does not look like it's aligned so that an operator can easily see and monitor the pressure from that vessel. So what we would do in that situation is we would introduce a Swagelok tube adapter as the integral end connection. So what this tube adapter does is it eliminates any alignment problems. So if you think about turning an NPT connected gauge into a port, you've got a pretty slim chance of that thing aligning just perfectly so that your operator can easily see it. With the tube adapter, you can just slide it into a Swagelok tube fitting and install it in 360 degrees so you can get the exact alignment that you need. There's no galling issues, reinstallation, using more or less tape, having it over or under tightened. There's a lot of things that this eliminates just simply by using the Swagelok tube adapter. One of the other things that we offer as an option is custom dial faces. So we can do different colors, we can add company logos, different scales. Basically, any markings or any artwork can be put onto a pressure gauge face. We have a really easy process to do that. We would just work with you on the logo. We would get the colors right. We even add the Pantone numbers to make sure that we get the exact color match. We provide a drawing and then agree on what that's going to look like before it goes to production. So we are eager to learn more about if there's an opportunity for us to do a custom faces. And if you're like me, my vision is getting worse, not better. So we have some low light options. Typically, a lot of places, pressure gauges are in rafters, they're under equipment, they're in a dark boiler house. Pretty hard to see them at times. So we do have some options on easier to read faces, that are easily read by flashlight with low light options. So we've got a lot of different options on making these gauges easier to read. And then as promised, the last thing I want to talk about and make sure that we all were familiar with was this acronym that we use called STAMPED. And this is the guide that we use for a number of different products. If you've joined us for our Flex Hose selection webinar, we've used the same acronym, but it works for pressure gauges as well. If you can design a system and then when you get to the instrumentation point of that project and really thoughtfully consider what gauges to use in those processes, these are the 7 pieces of information that you need, and you'll get much better productivity. You'll extend the lifespan of your pressure gauges by answering these. Looking at the size to begin with, do you want an 1.5 inch or a 6-inch gauge or something in between? You need to figure out what the temperature is, and not just within the process, but the ambient temperature, the temperature in the room. What kind of application am I putting this pressure gauge in? And then, the A for application is just the sort of holistic approach of thinking about, okay, this is going outside, or this is, I have potential vibration over here. I need to sort of think those things through and, carefully consider what sort of options to use. The media, we really look pretty closely at what can happen with corrosion. So you definitely want to make sure that all the wetted components in your pressure gauge are agreeable with your system media. We talked about the pressure range and the rule of thumb of doubling whatever your optimal pressure is and using that as your size range. Or as your pressure range. So we have a lot of different options within the Swagelok gauge offering with pressure ranges. The end connection, I know I need to stop bragging about the tube adapter end connection. I get it, but it's just so easy to use. It's safe, it's repeatable. You have 360 degrees of putting that face where you need it for your operator to easily see it. So, but you can use MPT, you can use, whatever else is, works in your system, but know that tube adapter end connection is readily available. And then we did talk a little bit about the delivery and availability of not just grabbing what's in stock, but stocking what you need for that system. And I think that's a big part of it, because you can answer all those other questions, but if you just grab what's available, you run the risk of premature failure with these gauges. So that is it. So I want to make sure that everybody gets that selection guide. And I know this presentation will be available as a video, and we'll have some follow-up information to send to everybody. But I'm going to open it up for questions and comments from the group. If there's anything that I didn't explain very well, or if I could go into more detail, or you have questions about, I'm here to help. Dayton, if you could let me know if there's any questions.
Yeah, we have another great question here. Is the 2-to-1 ratio that we use when we're sizing the pressure range for an application also applied to vacuum gauges? So meaning there are gauges that read both vacuum and pressure, positive pressure.
That is a really good question. I don't know the answer to that, but Dayton, if you could make a note, we will absolutely follow up with you on that.
Yeah, absolutely.
Good question. I knew there'd be at least one that I definitely could not answer. And folks, if you think of a question this afternoon, tomorrow, next week, you have our contact information. Please email it to us or call the office, and we will do our best to answer the question and help you. All right. Well, Dayton, if there's no more questions.
Yeah, I think we're good. We're good.
All right. Well, folks, I hope everybody learned at least one thing that they can take with them to help them when selecting pressure gauges and or identifying failures in the field, and knowing the why behind what has happened, and extending the life of future gauges.
Oh, hey, we do have one more question here, real quick, Dan. Can you refurbish gauges?
You can reinstall them. I don't know about refurbishing as far as like replacing a board-on tube or replacing the movement.
Yeah, I think that's kind of where we're going with that. I think once the board-on tube is damaged, that it's done.
Yeah. So I believe the answer would be no, that we don't have like a rebuild kit for a pressure gauge. Yeah, we don't offer that right now. It's a good question though.
All right.
Okay. Well, very good. Well, thank you, folks. I really appreciate everybody's the good questions, the interaction, and y'all being here. Thank you so much.
Thanks, everybody.